Hello friends, welcome back to BioLectures. Today here I will make you understand the basics of spectrophotometry. I am bringing a series on spectrophotometry, different types and their functions. So please subscribe this channel and hit the bell icon for notifications. So let's begin. So a spectrophotometer is an instrument that is used for identification of chemical substance, its concentration and absorbance over a range of wavelength. Instruments that are used to measure optical transmission or reflection characteristics of a sample over a range of wavelengths are termed spectrophotometer. When over a range of wavelengths are passed through sample, some of the light is absorbed and some of the light is transmitted. So a spectrophotometer detects the transmitted light and it shows the absorbance, concentration and the identification of chemical compound in the sample. A spectrophotometer consists of two instruments. First one is spectrometer and second one is photometer. Spectrometer is for producing light of any selected color or wavelength. The light source prism grating produces different kinds or different wavelength of lights that come under spectrometer. And photometer is for measuring the intensity of the light. When light is passed through a sample, some of the light is transmitted. That goes to photometer. And photometer converts this light into current that is shown on the screen. So this current is proportional to the intensity of the light beam that is coming to the photometer. So photometer is a detector. The detector in the photometer is generally a photocell in which a sensitive surface receives the photon and it converts these photons into current that is proportional to the intensity of the light beam that is reaching to the surface of photometer. An absorption spectrophotometer is a device that is used to measure absorbed light intensity as a function of wavelength. The electrons in molecules and atoms reside generally at the ground state and they need energy to get excited or go on higher energy level. The difference or the energy difference between these two its state is equivalent to the energy of the wavelength that is absorbed. So the equivalent wavelength energy is absorbed here and it creates the absorption spectra. When it goes on the higher energy state level, it will come back to the ground state. The energy is emitted here that creates the emission spectra. So in UV visible spectrophotometer, a beam of light from suitable UV and visible light source is passed through a prism or diffraction grating monochromator. The light then passed through the sample to be analyzed before reaching the detector. Here the UV and visible light sources are deuterium arc which produces UV radiation. It produces 190 to 330 nanometer wavelength. And tungsten filament lamp produces visible range of light or visible range of wavelength. If someone wants to use deuterium arc or UV or visible light, so it can switch between the deuterium arc and the tungsten filament lamp. If someone wants to use both of these wavelengths, so these lamps are used together to generate light beam across the 190 to 800 nanometer spectral range. In UV visible spectrophotometer, 5 main components are here. First one is the light source where deuterium arc and the tungsten filament lamp is used. A monochromator which can be prism grating. It is called as monochromator because it separates out each wavelength. A sample holder where cuvettes are used. Cuvettes can be made up of glass or quartz. Detector that detects the light and convert it into current which is shown on the screen. An interpreter which shows the graph between the absorbance and the wavelength. Now we will understand the mechanism or function of the spectrophotometer or instrumentation. This is the light source. Here deuterium arc and the tungsten lamp are used for creating ultraviolet to visible range of wavelength. This one is the collimator. It is a lens that is used to concentrate all the lights on prism or grating. Prism grating is called as monochromator because it will individually separates out all the wavelengths. This is the slit or wavelength selector which selects the particular wavelength that will pass through the sample. I0 is the intensity of the light that will pass through the sample and I is the transmitted light intensity which will go to the photocell or detector. Detector will convert this intensity of light beam into current which will be displayed on the digital display. This produced current is proportional to the intensity of the light beam which touches to detector. Here photodiode or photomultiplier tube are used if single detector is we are using. And arrays of detectors can also be used like charged coupled device or CCD or photodiode arrays, that is PDA. Whenever we are using spectrophotometer, first we have to select the wavelength which will pass through the sample. And second one, we will have to adjust the reference. Reference is a solvent in which our sample is dissolved. We will use reference here to compare our sample with the reference. Here we will set the baseline 0 with the reference or the absorbance 0. So that's why we can compare our sample from the reference. In first run we will use reference here and set absorbance 0, and in second run we will use our sample here and we will run the spectrophotometer. It will show the absorbance here. Whenever the light is passing through a sample, some of the light is reflected, some of the light is absorbed and some of the light is transmitted. This is the incident light beam. Here I are always kept constant because the absorbed light and the transmitted light is sufficient to measure. When monochromatic light or specific wavelength passes through a solution, here Beer's and Lambert's law are follows. What is Beer's and Lambert's law? I have already told you in my previous lecture and the link is given below. You have to go through to understand what is Lambert's and Beer's law. Lambert's and Beer says that the absorbance is proportional to the concentration of the solute and the length of the light that is passing through the sample. Whenever a light is passed through a sample, this kind of graph is created. On y-axis, absorbance is shown and on x-axis, wavelength is here. Using this plot, you can interpret on which particular wavelength absorption is maximum. Here, chlorophyll B shows maximum absorption at this particular wavelength and chlorophyll A shows maximum absorption at this particular wavelength. So this can be used to interpret the maximum absorption at particular wavelength. Now the uses of spectrophotometry. Spectrophotometry is widely used for quantitative analysis. In the starting of this lecture, I have told you that is used for identification of the chemical substance, its absorption and the concentration of the chemical compound. So it is the quantitative analysis of the chemical compound. It is used in various fields like chemistry, physics, biology, biochemistry, enzyme catalyzed reactions are read here, materials, chemicals, clinical application and industrial application, etc. Wherever the chemical substances are involved, this technique can be used. I hope that I have nicely delivered this lecture. If you liked my explanation, please subscribe my channel and share this knowledge with your friends. Next time I'll be again available with very interesting topic. As I have told you that I am coming with the series of spectrophotometry. So for the next time I'll be here. Till then, goodbye and take care. Thank you.